Okay, so today what we're going to look at is domain and range of different functions. So remember that domain is all of the x values and the range is all of the y values. There are different notations in which we can write domain and range. We are going to look at inequality, set, and interval notation this year. Depending on our graph and what notations we see on there, like circles and arrows, that's going to tell us what exactly we're going to write for any of the three notations. We can use any of the three to express the same information, but you may be asked to do one or the other. One of the things you might see for an endpoint are circles. If they are open, that means that the graph stops right before it gets to that point. And we're going to use less than or greater than for inequality notation and set notation. For interval, we would use a parentheses. Closed circles, like what we have at the endpoints, for example, 1, mean that we have an equal to as part of our inequality symbol. And for interval, we would use brackets. When we have arrows, that means that the graph goes on forever. We'll use the number infinity or negative infinity, which looks like a sideways 8. So negative infinity would just have a negative sign in front of it. And we'll always use less than or greater than symbols with infinities. We can never be less than negative infinity or greater than infinity because infinity means forever. So if we were to literally count for the rest of time, that is what infinity represents. Same deal with set notation. You might also see all real numbers, depending on whether it goes into infinity in both directions or not. And for interval, we'll use parentheses again because parentheses mean we can't reach that value. So if we look at example 1, let's just go through inequality notation first. We have closed circles on both ends. So as we go left to right, it starts off at -6. We have a closed circle, so we use less than or equal to. We're going to put an X there because this is our domain. And when we get all the way over to the right, we have another closed circle, so we use less than or equal to again. And that is 9. For the range, we go from bottom to top. The lowest value is at -4, and the highest value is at +2. Because the line goes through that point, it'll be a less than or equal to. Why? Because this is the range. And it goes all the way up to where y equals 2. So it is important when you're doing this that you make sure you're using the x values for the domain and the y values for the range. So this is the point, -6, 2. So -6 gets used for the domain, and +2 gets used for the range. Let's do another one. For the domain, all the way on the left, we've got a closed circle. And then on the right, we have an open one. The x value for that point is -3, less than or equal to, because we have that closed circle. This time we have an open circle on the right, so it's going to be a less than symbol instead of less than or equal to, because we're never actually going to get to that point. And for the range, these won't always be at the same places, but in this case they are. Less than or equal to because of the closed circle, and less than because of the open one. Okay. So all the way on the left at -1, we have a closed circle. And then on the right, we have an arrow. So the arrow means that it goes forever. So it'll be less than infinity. When you have one of them that has an infinity, so one, not both, we could also write it like this. Either way would be perfectly fine. But we can only do that when just one of the ends goes to infinity. Otherwise, we have to do the one with the most symbols there on the left. This one. For the range, the lowest point is right here at 0, -5. And then it goes up to positive infinity. And again, because just one of those sides goes to positive infinity, or even if it went to negative infinity, we can write it with the 3 pieces instead of the 5. Now let's look at interval notation. We're going to end up using the same values, it's just going to be written a little bit differently. So because we have those closed circles, we're going to use brackets. So those are the ones that look like half a square. And it'll be -6, 9. For the range, it'll be from -4 to +2. And again, we'll use brackets because we have closed circles, we have lines going through the point. So we know that the graph can reach that value. Because we have an open circle on the right, we'll use a parentheses. And same thing with the range. Closed circle uses a bracket, open circle uses a parentheses. We must include the infinity and interval notation, and we're going to use a parentheses for it, because just like with the open circle, the graph never actually is going to reach that value. If you're having trouble drawing an infinity, just turn the paper sideways and draw an 8. So now we're going to do set notation. Set notation uses curly braces. When you're drawing them, if you're having trouble, you're going to do almost like an elongated S. And then you're going to do the reflection. We've got some special symbols in here that we're going to use. So we have X. Then we're going to draw a vertical line. The vertical line means such that. X. That E means is an element of, which means that it's part of all real numbers. So any number that you know of right now is a real number. It is important to say real numbers because we are going to look at different types of numbers this year, and some of them won't be part of real numbers. Then we put a comma, and from there we're going to take this entire notation and write it down there. Same thing for range. Y such that y is an element of all real numbers, and it's between -4 and +2. X such that x is an element of all real numbers. More specifically, -3 is less than or equal to x is less than 6. It's always going to be that inequality notation for that second part. And that's the only thing that's going to change. It's always going to be x such that x is an element of all real numbers, comma, whatever that inequality notation is, or y such that y is an element of all real numbers, and then whatever the inequality notation is. So the only thing you're going to have to do differently for each one is that inequality notation part. So if you could do inequality notation, you can do set notation. When we have a graph that goes from negative infinity to positive infinity, like this one does for the domain, we do the same thing we would normally do for inequality and interval. But the nice thing about this for set notation is that we can just stop right there, because going from negative infinity to positive infinity is the definition of all real numbers. So there's not a way to get more specific with that. All right, that's all we got for you.